Hello, everybody, and welcome to Hash Rate. My name is Mark Jeffrey. My guest today is Jackie Peters, the founder and CEO of Blind Insight. Hello, Jackie. How you doing?
Hey, Mark. I'm great. How are you? Thanks for having me.
My pleasure. Thanks for being here. So we're here today to talk about the Coinbase breach and what happened, what they might have done to prevent it, and what they should do going forward. So why don't we just start off first describing in detail exactly what happened with Coinbase. So give us a quick little overview as so you understand it.
Yeah, so last week, Coinbase made public that they had received a ransom request that bad actors had gotten a hold of 70,000 customer records, and they were demanding $20 million or they would put the data to use. And the problem there is the data they got included both their home addresses and their wallet balances. So
of the Coinbase customers, yes.
Exactly, yes. And so a lot of these people are now at serious risk. And some of them may not even know it, right? Imagine you had a Coinbase wallet from years ago and you forgot about it and it's all of a sudden worth a bunch of money. So that's essentially what happened. And the way it happened, and this is something that we have heard about over and over again. It's a use case that I talk about all the time is they had a customer service center that was offshore. And I don't think it really matters that much that it was offshore because this could have happened even if it was in-house. And an internal employee was bribed to sell the data to these individuals who then demanded the ransom.
As usual, it's not about hacking the computers. It's about hacking the humans that control the computers. It's the easiest way to sort of, get into a computer. Like, don't worry about the technology. Just get inside the human's head and make them do something they shouldn't do. And sort of like 90% of the time with these hacks, it's usually the humans. So
yeah, that's usually the case. I mean, it's very reminiscent of the Okta breach in 2023, which was not an employee selling the data, but it was the same thing, customer service. In this case, it was a phishing scheme. So one employee clicked one wrong link and it wiped over $2 billion in market cap in a single trading day for them.
Oh, my God. So, so going back to when you're talking about the danger, you're talking about physical danger, right? So there are people who have Coinbase accounts, which may be worth a lot right now. And because their records and their home addresses were exposed, there's been an uptick in physical assaults on owners of crypto because if they can figure out where you live or, get into your hotel room or something like that, and if they can get your crypto, right, by, putting a gun to your head and saying, all right, unload your crypto wallet into my crypto wallet, there's not a lot the authorities can do, right, because crypto is permanent. It's not like they can reverse that transaction unless they catch the thieves and get the thieves' crypto wallets. And I know a lot of these sort of high-profile people in the crypto world, and there are a few who have actually withdrawn from public view because they've been assaulted. And most famously, the CEO of Ledger was kidnapped and held for ransom, and they cut his finger off. Right. So I mean, this is
wasn't
a very.
His wife with him too? I think wasn't it him and his wife, or was that a different case? But yeah, there have been a few cases of that happening, and it's not only that. It's even just these people's fear that they're in danger, right? So it's not just their physical well-being, but it's also their emotional well-being that now I have to be, on guard. And this all can be avoided.
Yes. We'll get to that in a second because I do want to hear your thoughts on exactly how we should avoid these things. But just to sort of continue to profile the event that happened. So the people who were working in the customer support data centers, they were bribed. So it wasn't like they were socially engineered. They were just paid. They were socially engineered through paying them to reveal this information. And I guess it had been going on for a long time. And there was also a reimbursement that Coinbase announced cost somewhere between $180 million at the low end and $400 million at the high end. So this cost real money. So I guess funds were stolen. And we don't really know the details of how the funds were stolen. I don't think. I haven't seen anything on it. Do you know more about that?
I don't know about stolen funds, or whether anybody stole any actual funds or not, and I don't know if there's estimates are based on damages, right? So are there SEC fines that they now have to pay, or are there lawsuits pending and things like that? So we need to dig into that a little bit more deeply.
Okay, so this happened. This is obviously horrible, and Coinbase, I guess, was forced to reveal it. And I guess it happened a while ago, and they're only now. I'm not sure why they're choosing now to reveal it. I guess they were told to, or they were forced to, or they just decided now was the time. Do you know why the timing happened the way it did, or is that?
Well, so I think there is a period of time between when the event took place and when they learned about it. And then once you learn about it, of course, you're going to spend some amount of time consulting with your lawyers and your team and trying to figure out, right, the best way to approach this, across functions in the business. And so I think it was a combination of those two things that I think the event happened, I believe it was November, December of last year. And then they found out about it, I think, a couple of months ago, or maybe it was in March, I think, that they found out about it. And then they announced it last week, and that was probably all figuring out what to do. But I know, in the case of a breach, when there's sensitive data, you have to, right? So they could get, serious regulatory impacts if they hadn't notified people.
Yeah, and this comes at the moment where Coinbase is about to be included in the S&P 500, and so this casts a little shadow over Coinbase. It's not really the look you want to have going into this new ascension to one of the thrones of finance, right? So, okay, so this is bad.
Yeah, it's not.
We all agree. Yeah. So what could Coinbase have done to avoid this situation, and what should they do going forward?
So there are a few things. A lot of folks have said, "Oh, well, you could have take this stuff in house, right? Don't outsource this, don't offshore it." That's true, but there's bad actors in house also, right? And so that doesn't really solve the problem. And so it really boils down to data access controls and how you manage your data. And there used to be a paradigm where if you wanted to use your data, you had to have that data in plain text, right? So if you want to build a call list for a call center, you have to run those filters on plain text. And then when the call center employee picks up, or anybody that has access inside that firewall to that data, right? Because you either have to encrypt it and keep it at rest and not use it, or decrypt it and use it. So I know homomorphic encryption, zero knowledge proofs have been getting a lot of buzz for a while in the Web3 community. We've been working on a different approach than that, but there are tools out there where if you combine some of the latest and greatest in encryption and use with fine-grained access controls, you can really limit exposure. So in the case of the call center, you can filter down your call list on encrypted data. When the call comes through, the call center employee can pick up the phone. They can be handed keys to decrypt the fields they need to do their job, plus some aggregate data, like maybe sentiment analysis on previous call transcripts, without revealing them, so that business can still happen, but the data stays protected. So 99.9% of the data stays protected 99.9% of the time. And at no point is enough data ever exposed for anybody to really use for anything nefarious.
So so first of all, do we know? Yeah, it does make sense. I'm going to ask you some more specific questions about what you just said, but before we get to that, do we know much about what Coinbase is or is not doing? In other words, do we know that they're not doing these things already? Or are your conclusions that there's no way they could have been doing them because the data breach happened, so obviously they're not? What do we know? And what
I mean, I would say, given that a lot of this stuff is relatively new and emerging technology, that an offshore call center wasn't very likely to have that in their stack anywhere yet. And so, I mean, there are very few enterprise grade deployments of encryption and use technology. And so I think that it's probably unlikely that this customer service center would have had that in place. Yeah.
Okay. All right. So let's talk about what you said. So what you're proposing is basically the call centers, the data is like basically encrypted kind of always. And when a call comes in, the representative only gets access to the little bits that are required to handle the call. So you're sort of being really stingy with the data. You're like, okay, here's a crumb, but it's the crumb you need and only the crumb you need. And you don't get like just sort of free ranging access to absolutely everything about Mark Jeffrey. You get like the little crumbs you need to handle my call, and that's it.
Yeah, exactly. And this is a problem that can be solved in the user interface, right, by limiting exposure, except that it doesn't really solve the problem all the way, because as long as someone has access to the actual database, they have access to the plain text, even if it's not served up at the application layer.
Oh, interesting. Right. So basically, like sort of the people that are working on the system in the background, you want to protect against the software engineers getting access to this stuff sort of in bulk as well. Is that basically what you just said?
Yeah, essentially, anybody who could have access, or gain access, right, who has access to the system on that level. So.
Yeah. Okay. And you talked about homomorphic encryption and zero knowledge proofs. I think my audience is somewhat familiar with ZK proofs, because that comes up a lot in the crypto sphere, in the BitTensor universe, in which I've been sort of had my head stuck pretty firmly for the last 6 months or so at the very least. But the homomorphic encryption part of it, talk a little bit about that. What is that, and what is that typically used for?
Yeah, so homomorphic encryption has, been receiving a lot of buzz for the past decade or so, I guess, and it's very powerful. Homomorphic encryption is a privacy-preserving cryptographic techniques that allows you to perform analysis on data while it remains encrypted. And so HE holds a lot of promise. It is Turing complete, meaning that you can kind of do anything with it, but the way that you actually do those things, the only thing it's capable of is addition and multiplication. And then you can do subtraction and division, you use negative numbers. So to do any kind of analysis, you have to break everything down to binary. And so if you can imagine what that would look like on like a document with fuzzy matching and sentiment analysis and all this stuff, and it's very, very computationally expensive. If you ask my co-founder, Nick, he would tell you probably 5 to 10 years off before it's really practical. So when I had the idea for Blind Insight, this was back when I was at Orchid in about 2017, 2018, and I started learning about this stuff. HE held a lot of promise, and then I quickly discovered that we couldn't have done the kinds of real-time analysis that we're doing. So the call center use case would fall apart. It would take you 2 days to build your call list.
You'd have to you basically calculations on encrypted data would be finished when the sun swallowed the earth. It's like that sort of, maybe not that big, but like that's the basic idea. So yeah, they're just sort of impractical for everyday use. Yeah, I did have so exactly. I don't know if you've heard of Nillion, Nillin. Yeah. So Nillion,
they sound familiar.
We did have Nillion on the show previously. Yeah. So they're sort of playing, they're not doing exactly what you're doing, obviously, but they're sort of similar in that they're performing operations on encrypted data. And I learned a few things from that interview that I didn't know. One was what you just said, is that you can perform Turing complete operations on encrypted data, but it is limited and it is computationally expensive. And we've actually known that you can perform operations on encrypted data since like the 80s because the mathematical proofs. Yeah, the mathematical proofs were available to us to know that it was possible. We were like, okay, the math says like you can do it.
Yeah, and there was really work in like private set intersection and private information retrieval in like the mid 90s, right? And I think Oblivious Realm even goes back to the mid 90s. So there's definitely work in that direction going back many, many years.
Yeah, so it sounds like, so let's just talk about Coinbase implementing this stuff like practically. With homomorphic encryption, it's not really doable right now because it's too slow and too computationally expensive, correct? Okay.
Correct.
So along comes Jackie Peters and and her new company, Blind Insight, which is an homage to the encrypted data. You can get insights from it while being blind to what's actually inside the black box, right?
Yes.
So, tell me how do you solve this problem, and what could you have done, or maybe could do, for Coinbase in the future?
Yeah. I'm so sad we couldn't have helped them before this happened. And so, so what happened was, so I had this idea for a while and I was kind of sitting on it and I was talking to people about it. And a good friend of mine, an early advisor to the company, needed something like Blind Insight to do a privacy preserving auction marketplace for his Web3 project. And so when I told him about the idea, he was like, "Ooh, I need that." Right. And so I was at Orchid for a couple of years, and then I left and I was at a cloud AI radiology startup and kind of out of tune with Web3 and privacy, crypto protocols and all of this stuff. But then at the end of 2021, he sent me a research paper that was a graph-based approach. It was called Graph SE squared. We actually pivoted away from that approach into an index-based approach, but broadly, we're using techniques like searchable encryption, and it has a cousin, searchable symmetric encryption. And it's not fully Turing complete. You have to incrementally build on different kinds of operations off of the same core index-based approach that we take. So what that means is, okay, when we first launched, the POC, we just had equality. You could do exact string matching, right? And so then we launched number range operations. So you could do greater than, less than, equal to, and things like that. And now we're about to ship a subset of aggregation functions like sum and average and count and min and max. So we'll be able to start tackling actually some simple machine learning algorithms where right now we work better on like queries and structured data, SQL-like stuff. And so the core innovation is really in this index-based approach, which adds a bit of storage, which is cheap versus compute, right? But it adds negligible overhead over plain text. I mean, it's like millions of times faster than homomorphic encryption.
Wow.
Yeah.
Quite the improvement. So the sun will not swallow the earth before my query is complete.
Exactly. Yeah. I mean, we're down to about, depending on the complexity of the kind of query you're running, about 15 seconds per million records. And we believe we can cut that into about a third over the course of the next quarter or two.
And to dive into the sorcery by which you achieve this theurgy, a bit redundant, but just go with it. You basically have a different approach than homomorphic. Mm-hmm. You called it an index-based approach, right?
Yeah.
So can you tell us, like, sort of in dummy speak, like more or less what you're doing there?
Yeah, sure. I have a visual aid too, if that's helpful.
Yeah, sure. Go ahead. Try to share.
Great. I will share my screen. Figma. Okay. So the way Blind Insight works is we have this proxy architecture. So people who are building on Blind Insight can run the proxy anywhere that they would like to run it. So whether that's on-prem, in a private cloud, on a mobile library, right? So we would support, say, a self-sovereign identity type use case for Web3 because it could run locally on the client. That proxy is what accesses your keys and uses the bare metal to do the encrypt and decrypt. And so what happens is you have a data owner that has some plain text. It's sensitive. The proxy...
And that's all the way on the left in this diagram.
That's all on the left. Yep, okay. That's the data owner. And so this is great for like data sovereignty because the keys in the plain text stay over here, right? And then the proxy uses the data keys, but also the query keys to encrypt the data, right? So it uses a non-deterministic encryption algorithm on the data set itself. And what that means is that when you encrypt the word cat, it comes out differently every time. And then the query keys are a deterministic hash, meaning when you encrypt the word cat, it comes out the same every time. Make sense?
Yes.
Great. So what we do is we build an index of those hashed values to encrypted values. So there's now a hashed value of the word cat, but then there's a pointer to the encrypted record that we got that from. So when a data requester has the query keys, they can submit a query. We look for that in the index, and then we send them the non-deterministically encrypted record that they do not have keys to decrypt. So they can still run analysis on encrypted data without ever needing to decrypt the data.
Got it. So just to paraphrase, so you've added an index layer, which is also encrypted, to the actual data, right? So you've got like a middleman sort of, and that allows you to basically perform queries before the Earth is swallowed by the sun, and that's how you sort of escape.
Yes. So equality is very easy. I just talked you through it. Lots of engineering teams could build something that does equality, but when you get into things like number ranges and aggregation functions, free text search with context and fuzzy matching on n-grams, right? You need some pretty advanced strategies there. And so that's really sort of the core of what we've been developing.
Yeah, so you're making all those operations. Like I imagine it's way harder than it looks. And this is, we're sort of in the realm of deep brain math and all that stuff. And also it can't fail, because then you end up with Coinbase egg on your face.
Exactly.
And you are in the business of preventing egg upon face. So
exactly.
So it's got to be perfect, and it's got to be foolproof, of every time.
It does. Yeah, it does. And so this way, the Coinbase employee would have been a data requester, but then they would have been assigned data ownership keys to just the fields they need to do their calls via an API call. Yep. And then there's another API call that revokes those keys, right? And so we're basically obscuring away all of this like crazy complexity, and it looks a lot simpler than it is.
No, it's a very simple explanation, but the details are where it gets really gnarly. So so how would Coinbase engage with you? They'd basically, I assume that this is complex to set up, or relatively complex to set up, right? So you'd go in there. Would you have to consult with them, or do you work with entities that sort of implement your solution for you? How would that work?
Yeah, I mean, so, we've built it to be, to avoid vendor lock-in and to be easy to integrate, in the sense that everything is essentially APIs and JSON. And so this, database plugins, client libraries, and things like that. In the case of Coinbase, they were, again, outsourcing that to an offshore organization, and that's where the issue happened. So assuming they were to take that in-house, or assuming that that organization is now going to say, okay, well, we have to do something about it, depending on what their data store is, there would be a plugin or a library that would get built. So, for instance, if they're using HubSpot, we would build a HubSpot plugin, right? If they're using Google Cloud and BigQuery, we would build a client library for BigQuery. And so that's one thing that's on our roadmap right now, is we're building a connector, likely with cube.js, so that we can work with a variety of different data sources on Blind Insight.
Got it. And you guys, so I assume by now you're working with customers. You have some trial customers that you're working with. Like where is this in sort of, the product life cycle? Is it sort of in beta still, or is it actively being used by clients today?
Yeah, we've had a number of beta sign-up. We have about 80 beta users. A couple of those are paid. We've signed a number of LOIs and design partnerships. One of those is with UCLA Health, which is really exciting. And so we have gotten some early signs of product market fit. A lot CISOs seem to really like the platform.
Yes.
Yeah, and so we are still in beta, but we are about to ship KMS integration, which we will consider to be our V1. So that has been, right now, because of the proxy architecture, each user is tied to a proxy. And once we have KMS integration, you can have a multi-user scenario with a single proxy. And once we ship that, it will be easily deployable in production use cases and considered our V1.
Very cool. Well, I imagine there's a giant market for this stuff, so I think it could do extremely well. So
yeah, we're seeing a lot of demand from like big enterprise organizations, and so that's been, we know what they need, and we've been in beta, and so I think with the release of our V1, the KMS was something that a lot of people were looking for. We also found an interesting sort of moment in time use case with like growth stage companies that are selling to these enterprise organizations. And they're not even, for the most part, interested in the searchable encryption, but they want to prove to these, in some cases, highly regulated, but either way, as, a call center is a call center, right? So, and that data is sensitive. And so really interested in just having APIs to check the boxes for data encryption at rest and encryption in transit, plus the access controls and observability that we offer.
So it sounds like you basically got product market fit for something like a call center and definitely within the enterprise. In the Web3 universe in which I live and breathe, I imagine there are some use cases there as well. Have you been looking into that?
Yeah, we have. I mean, the idea for this started, as I mentioned, when I was at Orchid, and then our first customer was a Web3 project.
What is Orchid? Let's go there for a second. So, because a lot of people don't know what that is.
Oh, Orchid's a decentralized VPN. Okay. And so I was the founding product person there. I was actually the first employee there. And so I was there for a couple of years and got really, I was really interested in privacy at the time. Just concerned about data leakage and, how it was going to be used to manipulate people. So joined Orchid, learned about privacy preserving cryptographic techniques, kind of just, in the whole crypto circuit. And interestingly, Orchid, their privacy protocol was around payments. They were essentially like incentivized Tor. So they were using like normal onion routing protocols, but then they had a payment system called probabilistic micropayments, because payments are one way to track somebody to activity online, right?
Yep. So that was how you sort of got interested in this whole sphere.
That was how I got interested in it. Yes.
Yeah. So could Blind Insights help in the Web3 universe today? Is there a connection there or not?
Yeah, I mean, I think there definitely is. So the fact that we have this proxy-based architecture means that we can support. So one example would be, self-sovereign identity, right? Which is a concept that's been around for a while. And self-sovereign identity is really great for a use case like I'm going through the airport, someone asks me for my passport, I'm going to show them my passport, right?
Yep.
But it does not work well for something like I'm a clinical researcher looking for people who have diabetes that might want to participate in my clinical study, because there's no searchability, right? There's no discoverability in that scenario. And so Blind Insight can be used as kind of like a middleware, so that a user, say, with their own data on their own device managed by themselves, would subscribe, say, via PubSub to match requests that would then be delivered to their device, computed locally, right? And then if it was a match, then you could let somebody know. And so we solved this discoverability problem that's inherent to the whole self-sovereign identity play.
That's pretty interesting. Yeah. And just let's talk about self-sovereign identity for a second. So that basically means, the way identity works today is the government issues you a passport or a driver's license or something like that, because there's a centralized authentication entity, which has dubbed itself as the authority on making sure that IDs are accurate and you are who you say you are. That's one way to do it. But in sort of the Web3, crypto libertarian fantasy world in which I love and which we live in partially now, it would be great if I could just prove that I am who I say I am and manage my own information. And there is no third party, human somewhere or government somewhere which bestows upon me the authentication of my identity. And
I think the word identity there is also used broadly, meaning that, I own my own data essentially at the end of the day, right? And so why should big companies own my data? and profit off of my data when I'm the one generating it, for instance,
Yes.
right? So a lot of companies like Brainfall, I think, is one, right, that are like doing this from like almost I think it's advertising or marketing or community buildings kind of a scenario. So yeah, and actually our company was originally called Sovereign Systems Inc. I don't know if you remember that.
Oh, yeah, I do recall that.
The original concept was based on self-sovereign identity. And then we realized, okay, there's a really small community that cares a lot about self-sovereign identity right now.
Yeah, the libertarian,
but interestingly, now enterprises are more and more interested in it because, data sovereignty factors in all sorts of international privacy regulations, right? So putting the data in the user's control, like the DPDP in India just passed new data sovereignty laws that are going in that direction, because I think it just solves that problem really well, right? But again, you now have the problem of discoverability, and also there's a UX problem of like managing permissions, right? Like nobody wants to sit there and be like, oh, I'm going to give this company permission to access this and this and this, right? So like it really all does boil down to the application layer at the end of the day, right? And I think that's in the case of Coinbase, in the case of, self-sovereign identity plays and stuff like that, right? It just has to be easy.
Yeah. So if I'm self-sovereign identity guy, and I'm a techno libertarian, person, which I am at heart, partially, not totally, but partially, absolutely. I've sympathized towards that. Then I want that, but I also want to be discovered potentially by Facebook or whoever, because I want to make some money. Right. And Facebook owns my data and sells that data to other people. I don't get any of that money, but they're just using my stuff. And, if I own my own data, maybe I'm okay with that, but I want the money, or at least I want a cut. Right. MJ needs to wet his beak, as they say.
Yeah.
Right?
Yeah, exactly. Yes. And then the data is stored and accessed in a lot of cases locally. Right. So, it's on you. You're not a victim of a data breach anymore because you have it.
Yeah. Yeah. Or I open myself up to the Facebook data breach, as it were, and I'm making some cake, right?
Yes.
Which maybe I want to do, but that's the way it should work. Right. So, we have AI. The weird thing also, like with AI now, AI sort of does that also because the training data is, data that we've all produced.
Yes.
Right? But Grok comes along or ChatGPT comes along, and they're effectively micro plagiarizing all of us and remixing it at such a fine grain that the answer, you can't really tell that it's ripping off from millions of people at once, but it is.
Yep.
Right. So so our data is being used without our will. Right. So should these companies pay us, fractionally for the neurons that are using our data, and can you even calculate that? Right. Big open question right now. But yeah, I think the answer is yes, that somehow we should be compensated for, the parts of our data that they're using. Right. So
yeah. And I know there are Web3 projects that are working on that. And there are projects going on also, on the healthcare side of things, as well, both centralized and decentralized. So it seems like a good time to be working in the space.
Yeah.
And, we'd love to support those sorts of projects. That's really our genesis, right? And so we're still don't have a mobile library yet, but anybody could theoretically build one. And to answer your question earlier in terms of like, do we have partners for integrations? I just wanted to leap back on that. We have chatted with some systems integrators, and I think it's a really good route for us. And I think we want to start off small with that, right? We're still kind of a little early. You have to get buy-in, right? So we're more interested in working with kind of like smaller shops that, want to have early access to some of this new tech.
Super cool. So where can people find you online if they are now curious, if they're now about implementing your solution?
Yeah, they can check out our website. We're at blindinsight.com. And we have our betas open. There's a free 30-day trial. You don't have to put down a credit card. We've got open documentation that you can find online. You can also find us on LinkedIn, Twitter, Blue Sky, Instagram, most of those places if you just search for Blind Insight. And then anybody who wants to can just get in touch if they want to contact us. There's a contact form on the website.
Super cool. All right. Well, I think we've covered it, and I really appreciate you coming on. We sort of organized this show last minute, so very, very appreciate your flexibility and willingness to come on and speak with us.
This was fun. It's funny. I texted you that LinkedIn post, and I was sort of like, hey, let's do a podcast. And you're like, how about tomorrow?
I'm like, yeah, sounds good to me.
Why not? Hopefully you got a good 25 minutes out of it or so at least.
Yeah, I think we got far more than that. So
great. Awesome.
All right, everyone. This has been Hash Rate. My name is Mark Jeffrey. We'll see you next time.
Have the AI observe the quantum double slit experiment. If it's able to collapse the wave function in exactly the same way as a human observer, then it's conscious like we are. There's someone at home in there.
Armand, your own father was part of Concordia. It was they who ordered him to produce the Musipocalypse. I'm chasing machine consciousness. Who will be first to make a soul in a mind made of metal? A real soul, electric sentience.
Metatronic.
This is a synchronicity engine. It is used to calculate a path through the world, one that produces favorable chance occurrences in order to obtain a specific result.
Look out! Drive faster!
I now know how to create an electronic peripheral that will allow for true conscious machines.
So this is the Atman project. This is not what I expected. Where are the military training camps?
Concordia believes that consciousness is primary, matter secondary. Reality, matter itself, is just a vibrational construct of frozen thought.
Here is a tale of a man's deeds and desires, of his quantum choices, of madness and twisted wires, his astrology encrypted and hidden from view. Only pyramids and shadows know the things that he'll do. Stop. Listen, I'll make you a deal. Me for them.
Your father didn't merely die in the challenges. Oh no, Verinder killed him.